Hi guys, my name is Kristen Moss, and I'm going to be talking to you guys today about how we can predict molecular shape. Alright, so to start off, kind of what is molecular shape and what helps to determine it? So it's determined by the number of bonding atoms and lone pairs of electrons that we have around our central atom. And to kind of help explain why molecules take on the certain shape that they do, we have the valence shell electron pair repulsion theory. And this theory just kind of tells us that our lone pairs of electrons and atoms are going to arrange in a way that maximizes attraction and minimizes repulsion to one another. Alright, so kind of some previous skills that you guys should have for completing these molecular shape problems is just drawing Lewis dot structures. So as a little bit of a review, we're going to look at the Lewis dot structure for CH4 or methane. So to solve this, we'll just go ahead and look at our periodic table, and we'll find carbon is in group 14, meaning that it has 4 valence electrons and would like to make four more covalent bonds just to satisfy its octet rule. And then hydrogen is in group 1 over here, although that one only likes to make one covalent bond. So with that, we know that we'll have carbon in the center, which is going to be covalently bonded to each hydrogen atom. And in this case, we actually do not have any lone pairs of electrons on carbon. Alright, and so to solve these molecular shape problems, what you're going to be using is a VSEPR chart, and I'm just going to kind of help you guys understand what this chart means. So on the left, we have something called the steric number. And basically what the steric number is that's just the number of groups we have around our central atom. And by groups, I mean it could be a different element, it could be a lone pair of electrons, and it can be some combination of these. And so then once we know our steric number, we can go down to that. So say we have 5 different groups. Then on the top, we have the number of lone pairs. So if we have 5 different groups and say 2 of which are lone pairs, then we just follow our chart and it looks like our molecule would have a T shape. Alright, so then solving just some examples with this, putting it all together. First, we're going to look at H2O or water. So once again, to start these problems, you're going to want to understand the Lewis dot structures, or I guess at least understand how many different groups we have bonded to our central atom and how many lone pairs our central atom has. So starting off with this one, we'll start with oxygen on our periodic table, which is in group 16. So we know it has 6 valence electrons, and it would like to make 2 covalent bonds to satisfy its octet rule. And hydrogen, once again, is over here in group 1 and would like to make 1 covalent bond. So with that, we know that we'll have oxygen in the center bonded to 2 hydrogens. And then it looks like we have two lone pairs there. So that would give us a total of 4 groups surrounding our central oxygen atom. So then using our VSEPR chart, we'll go ahead and we'll go down to the steric number 4 and then over to the 2 lone pairs. And that tells us that our water molecule is going to have a bent or angular shape. Alright, and then looking at one more example, we have NH3. So starting with our nitrogen, we'll go ahead and find that on our periodic table. Looks like it's in group 15, so that means it has 5 valence electrons and would like to make 3 covalent bonds to satisfy its octet rule. And once again, hydrogen over here in group 1, and each hydrogen atom only likes to make 1 covalent bond. So right here we can see that we have our nitrogen atom with the 3 hydrogens, each covalently bonded, and we have our 1 lone pair of electrons. So then going back over to our chart with our 3 atoms attached to our nitrogen and 1 lone pair of electrons, that gives us a total number of 4 groups, or a steric number of 4 again. Although this time we only have one lone pair of electrons, so it looks like that would give us a trigonal pyramid shape. Thanks for watching. I hope this helps helped you guys predict molecular shapes.